friends and neighbors. I want to talk about conic rotation. So here's an example, and we'll do it graphically as well as analytically. Determine the appropriate rotation formulas to use so that the new equation contains no xy term. We've got here a conic of the form ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. And in this example, a equals 1, b equals 4, c equals 1. Those are the key coefficients that we need to concern ourselves with. A, B, C. Now, d equals 0, e equals 0, and f equals -1. And it's always equal to 0 in this form. Now, to write your answer, you're going to have to write the word x prime, which represents the symbol x prime and y prime. What we essentially are doing is finding new x and new y, which rotate through the required angle. Now, I've got a written example here that it pulls up the theorem. If you're reading Stitz and Seeger, free open source text, version 3, version pi, what is it? It's version 3. It's the truncation on pi. Anyway, so suppose the positive x and y values are rotated counterclockwise through an angle theta to produce axes x prime, y prime respectively. Then the coordinates p of x, y and p of x prime, y prime are related by the following system of equations. So p are these the coordinates. X equals x prime times cosine theta minus y prime sine theta, and y equals x prime times sine theta plus y prime cosine theta. Now that's actually what we're asked to find. If we needed to go the other way, we could use these other equations. So I'm going to use these equations. Then I'm going to capitalize on another theorem, which states that the equation in this form of a conic, where b is not equal to 0, that is, there is an xy term, can be transformed into a new coordinate system, x prime, y prime, without an x prime, y prime term. In other words, we can get rid of that xy by rotating it through the angle theta. So we're going to rotate it through this particular angle theta, where cosine of 2 theta is equal to a minus c over b. So here we've got an example equation. 1, 4, 1, 0, 0, -3. So cotangent of 2 theta is equal to a minus c over b. And this is one of the rare times when you'll actually have a real use for cotangent. So cotangent of 2 theta equals that. Well, that is 1 minus 1, so a and c are equal. Anytime a and c are equal, then the angle of the cotangent of 2 theta is going to be 0. Okay, so we're divided by 4. So now we need to solve for theta. The cotangent of 2 theta equals 0. Take the arc cotangent of both sides. That is the inverse function to the cotangent. All inverse functions always behave the same way. Instead of putting in an angle and getting out trig function, you put in a trig function and get out an angle. That's how inverse functions work. It means you undo the function you had. So 2 theta equals arc cotangent of 0. I just found that it was 0 by computing the a minus c over b. And now I have 2 theta equals, well, the arc cotangent of 0 is pi over 2, and that's true because of we look it up on the unit circle, and if you input the cotangent of 0, you'll get the angle. You get the angle pi over 2. Yeah, so anyway, when we divide both sides by 2 in order to solve for theta, we end up with theta equals pi over 4. So now I need to rotate this through the angle pi equals 4. That can be done with the equations we have started with up here that we were given. So x prime times cosine theta minus y prime sine theta. Well, I'm going to plug in theta. I just found theta. I used the magic of inverse functions to find theta. It's pi over 4. X prime times cosine pi over 4 minus y prime times sine of pi over 4. Cosine of pi over 4 is root 2 over 2. So I can write this as x prime root 2 over 2 minus y prime root 2 over 2. That would work. Or I can pull out the root 2 over 2's. Very similar for y. It's essentially the same thing. It's just instead of minus a cosine minus sine, it's sine plus cosine. So that's how that works. Graphically, let's see what this actually looks like. So we start here with the need to rotate through the angle pi over 4. We're going to solve for pi over 4 using a calculator. Here's Excel. Pi over 4. We need to rotate through that approximate angle. I can copy this and paste it into the equation which I have entered here. And there it is. So this is our starting angle for our equation. Here's the equation. And here is the equation after I've rotated it. Now all I've done here is put this in standard form for this type of conic. And that will permit me to just replace the x's with x prime cosine theta plus y prime sine theta, and so on. It lets me plug in my x and y prime formulas, x prime, y prime formulas. Okay, so what we're going to do is just rotate this until we get to 0. And that will be that. Once we've rotated it, we can see that we end up with, I'm going to hide the original. Once we've rotated it, we see that we get a hyperbola that opens horizontally. That is, it's got, it opens horizontally. That'll be how I'll put that. And so here, let's draw the original again. We've rotated it from here to there, and thereby gotten rid of the xy term. And we can continue rotating as many times as we want. It's just there's no particular benefit. It's actually, there is one point here to be made, which is if I rotate enough, if I rotate far enough, I'll get another equivalent angle. I can't quite line it up. And that would overlap again. And if I keep doing this as many times as I want, it continues forever and ever. Okay. That is rotation of angles. The goal that we have here is to basically get rid of the xy term. In other words, the goal we have is to rotate it so that it's either opens horizontally or opens vertically. That's that.